There we go.
Hey, there we go. There's three of us today, and it's number 103. And it's the eve of Valentine's Day, everybody. Our 103rd episode of the Santa Barbara Astronomical Unit's weekly SBAU Astro Hour for the 13th through the 19th, 2023, done live from our respective computer rooms and man caves each and every Monday morning, 11 to noon, using Zoom, and viewable by our members and others interested in astrophysics on YouTube. I'm Vice President of the club, Mr. Ron Heron, soon to join the other talking heads on the screen, who I call the Brain Trust. Going to learn a lot, believe me. I'm the guy that learns, because I sure do. This week, we're going to talk about tracking the comet. E3 is still out there in green. Going to check out that dusty zodiac light out there on the ecliptic just after sunset. Darker skies as the moon hits the fourth quarter. Curiosity on Mars climbs into a central mountain in the Gale crater, and the Venus cuddling up to Neptune. How can that happen? One's inside our orbit, and the other's way out there, a gas giant. But happy Valentine's Day coming up. We got a nebula for you, a heart one by all means. And following the asteroids, including two Pallas and a new small one, a little problem out there for the James Webb Space Telescope. And we'll check out one of the small dwarf planets that might or might not have a ring around it. It's interesting. I can't pronounce it, but the guys will. Here are the guys. Our president for 5-6 years, wife Pat, Jerry Wilson. Hello, Jerry.
Good morning.
Had a great meeting yesterday that I'm sorry I couldn't attend. And then our incredible outreach coordinator, Chuck McPartland, also married to Pat. And Pat, his wife, is the merchandise manager. And I just have a feeling, Chuck, you live for those star parties when they're successful, because you just love people, don't you? They come in the dark and you show them your big heavy meteorite. Is that still out? You're still out there? How many did we have Saturday night?
312.
Wow.
Yeah. For a night with a 40% chance of showers, that was a pretty good turnout.
Well, as long as they got you on the screen, anything coming up that we can take on and check out and get vetted for?
Well, Friday is Westmont, but it looks like it's going to rain. So I don't know if that's going to happen.
Well, hell, we got our lake full. We don't need any more rain now. But give it a few months and we're going to need it. So,
yeah.
Okay, so just to recap, in case anybody doesn't know, on our first Friday night, we have our meeting online. Actually, it's live, but it's also viewable online.
Yeah.
Jerry, do you have any idea how many people are watching that on YouTube?
Right now? I don't.
Watching our meetings, our general meetings.
Oh.
We had about 10 the last two that we're watching on live, but then people can watch it later on YouTube, and you have to keep
the numbers grow a bit.
Yeah.
And we're getting
you can go to YouTube and look at them and look at the event, and they will show the number of people that have viewed it.
Okay, and everything's on SBAU.org, right? How to watch us on Mondays.
This show is under, I look it up as YouTube SBAU Astro Hour.
Oh.
But you can go to SBAU.org, which is our club's website, and you can get a link there to the YouTube.
Well, this is our 103rd show, and you know there's 52 weeks in a year, so we're coming up on our 2 year since we started March 1st of 2021.
Yep.
We got some silly science cartoons. They're always forwarded on a regular basis from Jerry Wilson's home, and they keep us laughing. And let's see what's out there. The two turtles meeting, one on its back. Right side up, Terrapin says to the upside down one in his shell, "Wow, never met an astronomer before." Opened his slot. And, I saw this and I thought about, I wonder how a turtle's neck vertebra handles that. I've never read up on it, but I'm curious as to what Mother Nature did.
Well, the turtle's bones are its shell. The vertebrae are fused into the shell. They're not an animal in a shell. They're an animal that has part of the shell, part of their skeleton on the outside.
Yeah, their ribs basically form the sides of the shell.
Right.
I'll be damned. Well, it somehow collapses, and here are the three versions of the same bolt.
Yes.
Different prices, same part. The one on the right for astronomers and for the Defense Department.
Yeah, if you do like I do and you build your telescopes or continually modify them, you can get all the hardware you need from astronomy websites and retailers, and you pay the price on the right. But if you know exactly what you want, you can go over to Home Depot or Miners and you can get the bolt on the left.
Yeah.
My first boss, Pat Wardlaw, owned a shop out in Goleta, somewhere off of, just up from Hollister Avenue, that just sold fasteners. And he'd have these real cheap. Across from
Yeah,
the-
there's, what is that, Precision Engineering? No, what is that?
I forget the name of
Specialty
it.
tool.
Specialty Tools. Yes,
Specialty
that's
tool.
that,
He
yeah.
he owned that. He and his
Yeah.
family. Yeah.
That's a very reliable place. If you can't find it most anywhere, you can get it there. And if you can't get it there, then you open the catalog to,
McMaster Carr.
yes, thank you. I
And
need
it's
more
true.
coffee this morning.
All right. Here is an object at rest. This is Isaac Newton's first law being depicted here. The housewife standing behind her at-rest husband in the recliner chair with a large load of dirty dishes about to crash it down on him. That'll prove it. That'll show. That's not Larson's Far Side, is it? No,
No, it's something else.
it's silly. Very scientific. Here are the two flies on the counter and the guy with the fly swatter about to squash them. One of the insects begs and pleads, "Don't kill us. We come from the future bearing an urgent message," which I assume would be insects will be taking over.
Mhm.
Time flies. That's what it's.
Actually, the someone in grad school showed me how to reverse that. Famous sayings. And the one for here is time funds when you're having flies.
Okay, here is that one from a couple weeks ago. Two that's two men fishing for frogs. See, Frank, one guy holding a flashlight. You keep the light in the eyes of the frog and you can bag him without any trouble at all. His partner standing next to him in the water, frozen stiff by the bright light of a UFO. Hovering over the swamp. They're both about to be sucked up. And us and them. This is more giving you a pause from the late Carl Sagan. Where is it? I'll just look at it. There is perhaps, he said, this is quoting, no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. I remember him saying that, us and them. Can you imagine if we had a whole world country, everybody got together and they got rid of all the borders? Who could possibly run for president of that? That's the problem, you know.
That you just blew my mind here. Trying
I'm
to think of
sorry.
that.
Politics and religion, they'll still find a way to divide everybody.
Yeah, well, you still got the blue and yellow flag of Ukraine behind you. And
Yeah.
I'm hearing predictions it's going to be a stalemate all through 2023 over there. And at least they didn't have that terrible earthquake to deal with. Wouldn't that have added to the war? Man. What shall we start with? The three of us. I'll learn and I'll ask questions. And here we go with temporary webmaster Jerry. Oh, the heart. Of course there's a heart. Where is it? In the sky, gentlemen.
You can see my share, right?
Yes.
Okay. It looks more like a butterfly to me, but I can see the heart in it too.
Okay, yeah.
It looks like
It's a
they're having
nebula. It's in our
electrical problem.
galaxy.
Yeah. This
Okay.
is a gas cloud in our galaxy that is shining by its own emission.
And they call it the Valentine Nebula or the Heart Nebula?
It's the Heart Nebula. It's in Cassiopeia.
Okay. Well, did it occur to you they also saw a heart on the surface of Pluto when they went by with newer?
Yeah, I should have put that one up too here. I didn't think of it at the time.
Yeah, I didn't either until just recently, just now. Is this where it
Yeah.
is?
Yeah, this is the finder chart for the Heart Nebula.
Uh-huh.
So here is Pegasus, and this is Cassiopeia.
Perseus.
Oh, you're right, Perseus. Thank you. Okay, the glasses come off.
So there's
So this,
4 or 5 constellations there with all those shapes in red.
yeah, the
Yep.
red things are one opinion of what they look like. This one still looks like a W to me, but you can spot this constellation too, and right between the two is this naked eye object, the double cluster, one of my favorite objects in the sky. 2 open clusters right near each other. And just off to the side of that, that's where the Heart Nebula is. The Heart Nebula doesn't have a Messier number. It's fainter than what you normally show to the people in our small scopes on outreach. It's something that the picture that was shown just a moment ago, that's something taken over a long exposure time.
That's the only way you can see it, is to use a camera.
It's the only way you can see it like that.
Yeah.
In a big scope, you might get a wisp of a faint fuzzy there.
Okay.
You can't change the exposure time on the human eye. The human eye has an exposure time of 0.04 seconds. And it's got an aperture of about
7 millimeters?
6 to 7 millimeters. Yeah.
Did I understand you to say you can't expose for a long time on your home?
With your eye, you can't make your eye exposed for a long time.
Oh, your eye. Got it, right.
Mhm.
But is it full of stars being made?
I don't think this one is that dense. I think this is just a case of there's some leftover gas around and a couple of stars nearby are illuminating it.
Yeah, I would.
But that's not the remnants of an exploded supernova?
No.
Yeah, I don't know what the shapes are like this. I have my own personal opinion that these shapes, when it gets knots and stuff like this, these are due to very weak magnetic fields that are out in space. And the dust kind of drifts along those. I'll look that up, see if I can find any information on it. But this is a very nice region to look in. There's a lot of things in this part of the sky. Now, this is more, this time of year, this is more toward the west.
Oh, it is. Okay.
Yep.
And in the next week or so, it'll be better seeing because the moon will be turning over.
The moon, yeah, the moon is starting to disappear from the evening sky.
I saw it up there this morning.
Yeah, in the morning sky it'll be there, but when it's at its last quarter, which is this week sometime, first quarter, last quarter here from the sun, when it's like this, then this is the morning side of the Earth, and this is the evening side. So you don't see the moon shining and ruining the evening sky. So you can observe fainter things and take longer pictures without fogging the image.
And that's tonight, by the way, the last quarter.
Yeah, the last quarter. Down
Okay,
here.
so we see a taco shell. And then
Oh, you call it, this looks like, when I see the actual moon like this, it still reminds me of that dime that you put in the March of Dimes card.
Yeah.
They don't do that anymore, but they used to hand those out at
I
elementary school.
remember I saved them, yeah.
Yeah, and the dimes were all silver, so they shone real well.
What's gibbous mean?
Gibbous comes from an Old English word that means humpbacked, and that's between those phases, between the quarters
10
and full.
o'clock.
It describes this combination of two arcs that are not concentric. If you
Oh, I
switch black
see.
from white here, you get a crescent.
Got it, right. Okay, fantastic. 28 days plus a few hours. That's
What's
why
that?
we have leap. That's
This,
not why we have leap. What?
The last quarter, the moon will rise at midnight. I think the last quarter is later this week.
No, I have it at the 13th, February 13th.
Tonight, okay.
Yeah,
Good.
new moon is on the 19th. And that's
Okay.
our time. That's not necessarily universal coordinated time. So it might be the 14th UTC.
Okay.
All right.
So let's go back and pick up the flow here. This is also the time of the year when you can see the zodiacal light, which
Yes.
if you're at a dark site, now this isn't the world's best picture, but I put it in here because it's unique in the fact that this picture was taken from the moon by Apollo something or other.
Oh,
Um,
right.
let's see, it was
Same astronaut that gave us Earthrise.
Apollo 15.
Oh, 15. Okay.
Yeah. So it is at this time of the year, the disk of gas and dust that lives in our ecliptic plane gets just the right angle with the sun to sort of show up as a faint haze. What it looks like is a city just over the horizon that's polluting the sky a bit. So
Are we seeing two stars in that shot?
I think there's 3 stars here.
Oh, that's a third one down
1,
below.
2, 3. Yeah.
Quite likely planets along the ecliptic.
It could be, yeah. Yeah, there's a number of stars over here.
Yeah.
Wow.
The camera was moving a little bit because the horizon is double exposed and the stars are streaks. It's probably a handheld camera. Or they took it out the window as they whipped over the moon.
Yeah, it looks like it's in orbit.
Yeah, it's looking down on structure. There's no big mountains or craters visible. So
They had to leave their lens open a few seconds.
is
Perhaps.
exposure? I have no idea.
That would give you the streaking though.
Yeah.
But this is something you'll never see on Saturday night star parties. Too bright here, right?
Not in the city. This is more something you got to be like camping up in Tuolumne or something. And you wonder what's that over there? You know, is it someone's campfire around the corner or over the hill?
Yeah. But it's not as rare as seeing the green flash.
They're not that rare. If you know what to look for and when to look, you can spot any of these things. I've been surprised by them because I live in a small town out here in Goleta where the skies are fairly dark, but they're not really dark. And when I go to places and camp like Joshua Tree or Tuolumne Meadows or something, or I set up my telescope at a remote dark site. One time I got angry because I felt a flush of anger because I set the scope up and there was a big cloud hanging right over the top of the sky.
Midnight.
What's that?
Midnight, huh?
Midnight. It was the Milky Way.
I thought it was the Gegenschein.
No, it could have been, but I realized at that time it was the Milky Way. And I thought, boy, you've been in the city too long because it was so bright out there. And the zodiacal light has done the same thing to me. I thought, gee, I thought I was way away from all the cities, and here's this bright spear sticking out of the sky.
But this zodiacal light that's, I guess, always out there, it's made up of dust and stuff left over from comets or from solar wind, or where does it come from?
Yeah, just general crap.
Just general crap.
Comets and asteroids.
So
Yeah.
it's thicker around the sun than anywhere else. It thins out as it goes. I wonder if they'd see it if you were on Saturn or Mars. Do you see it at all? Same concept.
You definitely see it on Mars. Saturn has those rings that might, overwhelm it.
Got it.
There's a famous question in beginning physics about if you're on a street, a dark street, and there's one street light, and you've dropped as you walk up the curb or up the street, your cufflink falls off on the ground. And so the question is, where do you look for the cufflink? And the answer is you look for it under the street light, because that's the only chance you have of seeing it. You can't see it away from the street light, even though you're sure you dropped it away from the street light. Your chance of finding it is very low. So the takeaway is you can't confuse the probability of finding it or where the light is with where it might be. And so that would be the case with your question about Saturn and stuff, seeing this light. The fact that we see it here doesn't mean it's not out there. It just means it's farther from the light source. So you can't tell that it's not there.
Well, I was seeing something that was talking about trying to attain maybe half the speed of light. It would be fatal, even with apparently atoms would become bullets. if you were going even half the speed of light,
Well, let's reflect on that for a minute. We had a cartoon a while ago about Newton's first law, but all of Newton's laws, and Einstein came up with special relativity that you can't go faster than the speed of light as a what is that, a postulate. But velocity, you can't tell velocity at all. So if there is an object anywhere in the universe that is moving at half the speed of light, then right now we are moving at half the speed of light with respect to that object. See, there's no difference. Speed of light the speed you're moving can't be determined. Only accelerations can be determined from inside the system. Velocity cannot.
Well, 186,000 miles a second's got to be compared to something.
It's
what is it? The nothingness? The
no,
universe.
the light travels at the speed of light, but it travels with respect to the measuring instrument.
And light, as far as we know, all those photons are just pure energy. They'll never go back into becoming matter. And
Okay, matter and energy are the same thing.
Yeah.
Remember, E equals mc squared.
Yeah, I understand that, but I'm told that the photon is the only particle that just stays energy. It never becomes matter.
Well, it has momentum. It has momentum.
Yeah.
Well, either not when it lands in an atom.
Yeah, you can move, you can feel it, you recoil from it. It's what's going to push light sails.
Huh.
Yeah, I remember there used to be an astronomer here in town that was talking about light sails on the radio, and he said, "Oh, light sails will never work within the Earth's magnetic field because it deflects the solar wind." And of course, that was totally wrong because it's photon pressure that powers the light sail.
Yes, and photons carry energy, but energy is a scalar. It's not a vector, so you can't get directionality out of it. When it hits the solar sail, the energy part only heats it up. The momentum bounces off, and the momentum's a vector, and that'll actually push something in a certain direction.
But light waves or photons aren't pushed, are they? They just automatically go from 0 to 186,000 miles a second instantly, don't they? Somehow. Science doesn't explain how, it just says that happens.
That's sort of an intuitive phrase that I suspect is probably not correct, but yeah.
And they can stop at an atom, can't they? And don't they travel around inside the sun for hundreds of thousands of years before they're finally jettisoned out?
They're absorbed and re-emitted continuously.
Okay, what absorbs them? The
Electrons around atoms.
Electrons? So electrons are not pure energy. They're somewhat of a piece of matter as well?
Yeah. They have a mass.
Okay, and they're smaller than the proton, yet they have the equal but opposite charge. Stuff I've always wanted to bring up to you, gentlemen. Thank you for kicking it around for me.
Sure.
Getting there. All right, so nobody on our club is looking at zodiacal light, unless it's Bruce Murdoch going up into the hills, maybe.
Well, it's something that happens at sunrise and sunset mainly. And within an hour or so of that, unless you're in a really, really dark site, then you can get hints of it all the way across the sky. And if you're up at midnight, you get you see another concentration of it called the Gegenschein, the anti-glow.
Right.
Is there a chance you might see Venus in the middle of it?
Yeah, because it's along the ecliptic.
Okay.
Yeah. Not the Gegenschein, but the zodiacal light.
Right. You'll never see Venus opposite the sun in the sky.
But how far out from the sun do you suppose it extends, your zodiac light?
Well, it just, the density of that stuff will go down the farther out you go, but it's probably pretty high out by the asteroid belt.
Oh, really? Not that far. And yet you can only see it right after sunset or before sunrise.
Well, that's when it's easiest to see.
Yeah.
So it's out there. And these aren't radiants. This is not a radiant thing that the Earth goes through.
Well, I mean, we're swimming in it.
But it doesn't give us, the zodiac light doesn't give us meteors.
Sporadics, probably.
Oh, I see. On a non-meteoroid night.
When you look up in the sky during a meteor storm and you see these real fast white streaks for meteors, those things are about the size of a grain of sand.
I know.
So that could be, I don't know what the size of the dust in the zodiacal light is, but it's not inconceivable that they could act as meteors if we hit some of the particles.
And if we go to Mars, we're going to have to get some kind of speed going. Any really bad speed beyond our, leaving, what is it, 17,000 miles an hour is
Escape
Leaving-
velocity.
That's for low Earth orbit, yeah.
any of those little sand granules in space you're talking about are lethal, aren't they? Would they go right through the rocket ship?
They can. There's some dramatic pits in the windshield of the space shuttle from just flecks of paint hitting it.
Oh, I'll bet.
So it's a real bad case of having a truck pick up a rock and hit your windshield driving down the road. And there you're only hitting it at 70 miles an hour.
Well, what's amazing to me is the Hubble, it's up about 400 miles, isn't it? So it takes about, what, two hours to go around the Earth?
It's up about 400. Yeah.
And yet
Sounds
it has
about
to
right.
stay, it has to stay locked in, whether when it's doing something like a deep field and not move it. They got it so
Yeah.
tuned that it can do that,
Yep.
Yes.
even though it goes behind the Earth and. what
Well, then
replace-
they look at something else.
Yeah.
Oh,
But
is that right?
they don't have to stare at it for 100 hours all at once.
And then they could reconfigure back to the exact spot they were looking
Yep.
at before.
Yep.
Wow. Well, this is fascinating stuff. I don't know where you want to go next, but there is a problem, they say, with the James Webb. I don't know if,
Oh, you want to go there? Let's see that.
well, serendipity and the James Webb Telescope. Failed observations of a specific target,
Yep.
JWST, resulted in something way more interesting.
Yeah.
Google's new version of AI had its high brain computer recently proclaimed the Webb took the first picture of an exoplanet. That was wrong. I don't know if you read that or heard about that.
Yeah. And the Google stock fell like 9% right after that.
Well, as far as taking a picture, I mean, nobody else can take pictures. We just know they're out there because of transit and other things, right?
Well, there have been images of them.
Yeah.
Have there? That weren't taken by the James Webb. Okay.
Yeah.
All right. Is this it?
Yeah.
This is,
How come
these are
it's
the,
orange? What is that about?
it's all false color. Don't worry about it.
Yeah.
But it's the night sky, isn't it? Shouldn't that be
Yep.
the black sky? Okay.
We make it black if you want.
Yeah. In fact, those little waves you're seeing there may be some of the zodiacal light.
Yeah.
I thought maybe it was part of Saturn's rings or something, but no, we're looking, what are we looking at here?
An asteroid.
Now, is this the one that, no, this is not the one with the ring. We're going to do
No.
that later.
That's later.
This is a little asteroid they found off of a bigger asteroid we knew about. We didn't know about the little one, but the James Webb.
It's
the
very
problem?
small and it's very far away.
So it's in
Don't
the
have a
belt.
lot of these.
Okay. And is the little one orbiting the bigger one? There it is. That's the little one or the
No.
big?
This is a rendition of a generic small asteroid. It's not the one. You can't get this good a picture from it. So it's just showing you a generic small asteroid.
Reminds me, $3 a pound for
It's
potatoes.
apparently 100 to 200 meters across
Okay.
and is probably the smallest object yet picked up by the James Webb. It's not named yet.
What was the problem? They had a problem, a failed observation. According
Yeah,
to
they were
your-
looking at something else and they got this instead.
Oh,
So this is the first image of that very small asteroid.
And there was something in the article that this was a calibration set of images anyway. So
Yeah.
they didn't expect to be finding anything.
I think it was the brightness of the bigger one, wasn't it? It's normally they're not bright like that. They look like stars. Or this one
It's
does.
the bright star down there is their calibration target, and they were taking pictures of that to calibrate the brightness of things.
And that is a larger asteroid.
Yeah, that's the larger object down there.
Yeah.
It might not be an asteroid, it might be a star.
And Ron, asteroid means star-like because that's how they appear in telescopes.
Is that right?
Yeah,
Hmm.
that was a term that I think Herschel came up with.
Ah, discoverer of Uranus or
Yeah.
Neptune?
Now,
Uranus.
this was, go ahead.
He
This was
was-
taken by one of the first images by the MIRI, the mid-IR instrument that hadn't been used before. So they turned it on and they're starting to use it. And they had that star there that they're looking at to calibrate. I do that when I take images through my telescope. I go to a star that has the same spectral class as the sun, and I take a picture of that. And then I can break that into 3 channels, and I can show the balance in between red, blue, and green that would give me the white of our sun. So that's to attempt to calibrate the colors. That's what they're doing here. They're calibrating the radiance, spectral radiance of their target.
Calibrating.
Yeah.
So they just pick any star or turn the damn thing until a star comes into view. And
No, you have to know something about the star. You have to know how much red it is and how much blue it is. And then you tune these channels to show the appropriate balance between these colors to give you the sort of a, see, they're more interested in the fine details of things. We're just interested in making pretty pictures, but they need to know how much of each kind of spectral band they have in there.
But would it be fair to say they aim the Webb at somewhere on the ecliptic is the main belt of asteroids, so that's out past Mars, right?
Yeah, well, some of them are in inclined orbits, but yeah, in general.
And so what they did, apparently they found what, about 1 million asteroids, and there's millions more, and they're an average of just under 1 million miles apart, I believe you said.
Yep.
So this is just another little one. There's no name for it probably, but it's how big? 100 feet across?
300 meters. So
900 feet across. That's a big rock. Okay, got it. What are those little?
Actually, the calibration target's not a star, it's a larger main belt asteroid. You may recognize it as 10920 1998 BC1, discovered in 1998 and measuring 15.7 kilometers across.
Okay, but every one of these 3 pictures shows some little dots around the smaller one that's circled. What are those little dots? Do they know those black?
No, those little dots, that's common. This is a raw image, and the little dots are dead pixel elements.
Oh,
So individual pixels. So what they'll do in the processing is one of several techniques, but the one I like to use is to take the 4 nearest neighbor live pixel elements and average them in 2-dimension and substitute that result for the dead pixel. So it gives a nice looking image.
that's right. They got to turn all those pictures that are taken, all those images.
Your eye has this kind of crap in it too, and your brain filters it out.
Yeah, I know. It's amazing. High def came along, and so okay. But it's a white dot that's circled, so they know that's an asteroid.
yeah.
By its motion.
And the other one, it's not orbiting the other one at the bottom.
No,
Right.
they're not gravitationally connected that way.
They're far apart.
Everything in the universe is gravitationally connected to everything else, but not so you'd notice it.
But only the Webb could see this. You
Okay,
guys,
now, the failure of the Webb was that these images here of the calibration target are saturated, and they didn't mean to saturate it.
well, I
So
wonder why
they're
they.
blown out. They turn completely white.
Yeah. And you got the spike coming off of it.
Well, I'm wondering if they enhanced the brightness so much that it turned the sky orange.
No,
No.
remember they code for each filter, they code what the color is that they're going to have that filter band in.
I see. Tim Crawford, if you're watching, submit a question online. Somebody, I think Chuck will watch. Here we are. Enlarge that turkey. You got it.
This is the asteroid with the ring around it. And this isn't the asteroid with the ring around it. This is Saturn with the ring around it.
Oh,
And showing the structure in the ring as a generic ring study. And this is the asteroid. They did not discover this asteroid just recently, but they did discover this ring around it recently. This is an artist rendition and not an actual photo. We can't see quoar.
Quawar.
Spelled
Quawar, yeah.
Quorar.
And it's
That
moon
clarifies.
Waywat.
Quorar.
It's got
Okay, well,
four vowels in a row. Q-U-O-A-R. No, Q-U-A-O-R.
One of those annoying Hawaiian words.
I don't think this one's Hawaiian. I think this is some Inuit or something for one of their ice gods.
Okay. That's
Ring
why
of
it's all
power.
repeated. They were shivering.
Yeah.
So this, I think, is larger than Pluto. Is that right?
No.
Okay, well, one of the recently discovered ones out there was larger than Pluto, and that's what started the downgrade of Pluto.
Yeah, that was Eris. They thought it was bigger than Pluto, but it's tiny bit smaller, it turns out.
Okay.
So it's out in the Kuiper?
Yeah.
Yeah.
Way out there.
And why do they think there's a ring? Or why did we come up with this picture that shows a ring?
Because they were doing it, they saw an occultation. Okay, where Quawar did not occult a star, but they saw two dips. So the rings passed in front of the star when Quawar didn't.
Quawar,
They were trying to observe an occultation by Quawar, where it
okay.
would pass in front of a star and make the star wink out. And instead, before the predicted time, they saw a wink out, and after the predicted time, they saw a wink out. And those wink outs were very small. So it was a ring around Quawar.
Yeah.
Why couldn't it have been a moon?
Because it showed on both sides of Quawar.
Yeah.
Oh, I see it. Okay.
That would
And
have
really,
to be a
those
very
ring
fast
particles are moons.
What'd you say, Jerry?
It would have to be a very fast and coincidental moon that happened.
Yeah. And you can think of all those ring particles as moons.
Yeah.
Well, are they now saying it's impossible to have a ring on a dwarf planet that size?
Obviously, it's not.
So they think there's a ring around one of the dwarf planets.
Yep.
And Haumea has a ring too, but it's within what's called the Roche limit. This one is unique because it's where they didn't think a ring could exist.
Yeah.
It's quite a bit larger than they would have thought.
The Roche limit is dependent, of course, on the internal stress tolerance of the object. And this might be orbited by a gravel pile that came apart, or it just collected a bunch of gravel.
Well, just like with Saturn, rings are spent moons, are they not? That pulverized and just occupied the whole orbit.
Well, that's because of the Roche limit where they get torn apart.
Mhm.
But in this
That was
case,
the
it
Roche
might have been an
limit.
impact thing. But they don't think so because, at least with the way they model the dynamics now, an impact ring like that would have dissipated over a short period of time. So they're thinking that for small bodies, they have to rethink what the Roche limit really is.
Okay.
And this could have been a small gravel pile moon that got,
Lots
ripped
of
apart.
little ones. Yeah.
I think, that's something with basically zero structural integrity. And so that may let you expand your Roche limit.
Huh. And it's never a shell. It's in an ecliptic. The rings are, is that what Roche limit is all about? That it's in a flat ring rather
Usually it's
than
in a ring, in a
shell?
plane. Yeah. I mean, but the Roche limit has other effects too. That's like when you have two near contact binary stars where one will expand out to fill its Roche limit. And once it reaches that, it starts spilling over into the other star.
Okay. However, the one we know was our ninth planet for many, many decades has at least one moon, and I think New
5
Horizons.
moons.
How many?
5.
5 moons around Pluto.
Yeah.
Well, this could have been 2 of the moons around this one, maybe. Just
Yeah.
happened to be a cult.
Have you heard the new number for Jupiter?
92.
Yeah, they just discovered 12 more apparently. So it has taken back the lead.
Well, they count even little rocks that are like small asteroids as moons, don't they? Mars has 2 like that, don't they?
Yeah.
Yeah.
Far
But some
out.
of these
So-
are like 0.2 of a kilometer. You know, I mean, you're talking little pieces of stuff around Jupiter.
But before this happened, what we're looking at on the screen, they knew that was out there because they had a name for it, Quoar.
Yeah.
And that means how do they name something they can't see? They never took a picture of it.
Sure,
This
they
is-
took pictures of it. They've got images of it. That's how it was discovered.
But they can't
just
see
don't
the
really-
ring.
Right.
Okay.
We don't see the rings directly, but we
Yeah.
know they're there. And they
We certainly
can
do
see
on Saturn, even with your amateur telescopes, but that's a different.
they see Quoar, but they can't resolve it.
Uh-huh. You think the web might be able to?
The web will give you better resolution.
Yeah,
I bet you they're lined up to use the Webb telescope around the world.
we're gonna have to fly something by to get the resolution we got with Pluto.
And they did use the web to get some of this, or not the web, I guess, but they're wanting to use the web. They used another large telescope to get some of this data.
You have any idea how much it costs to book time on the Webb telescope?
Couldn't afford it.
About as much as a Super Bowl commercial, $7 million for half a minute.
Wow.
That's what they were charging. So serendipity, what does that mean? What is serendipity defined as?
Sort of lucky good fortune.
Okay, gotcha.
It's how I think nylon was discovered.
Oh, is that right?
Yeah. A lot
Well,
of things.
You want to check out the comet? See
Yeah,
what
let me
it-
just say that serendipity starts with a scientist looking at his experiment and going, huh, what's that?
Yeah.
So,
Yeah, well, there were the Serendipity Singers. That's what I remember. They did Don't Let the Rain Come Down the Crooked.
oh, yeah,
Road.
that's right. Yeah.
That was the Serendipity. What are we looking at? Mars?
Yeah, this is part of Mars. See a little of their atmosphere around here. This crater here with this lopsided mountain in the middle of it is the Gale crater.
Ah,
And that's where we put a rover down.
that would be Curiosity.
Yes.
Perseverance, right?
No,
I think
according
it's
to
Curiosity.
Okay.
The other one was in God, I forgot the name of that crater.
Okay. Yeah.
the one for Perseverance.
Yeah.
Yeah. This is an older map, apparently. This shows landings on Mars. This is where Gale Crater is. This is where Spirit was, and Opportunity is Curiosity's in here. Viking 2, these are early stuff. Viking 1, Mars Pathfinder, Opportunity. And so this gives an idea of the whole disk. We're way away from the volcano, the shield volcanoes, Olympus Mons and things. We're at one crater that was believed to have a lake in it at one time. And this is looking straight down on Gale Crater. This shows that mountain in the middle. And drawn in is the suspected size of the lake from this river, the stream, and this delta that spread out. And so they landed in this region, and the entire time has been trying to get to the top of what is this mountain?
I think it was called Aeolus Mons, but they gave it a name, Mount Sharp or something.
Yeah, that's it, Mount Sharp. The lake was called Aeolus Palus, the hypothetical lake. So this is Mount Sharp from inside Gale Crater. It's not a real crag, but it's big, and it looks like it's drivable up there from far away. And this shows once they got to Mount Sharp, the bottom of Mount Sharp, they looked back into Gale Crater. This is where the lake region was. Now, I know this is really hard to see.
Wonder if it's as big as the one in Arizona.
Oh, no,
Oh,
this is way bigger.
much bigger.
Yeah.
Was it? It had to be a pretty good sized rock to hit Mars and make that Gale crater.
Yes, it was. Probably added some mass to Mars. This is at the base of Mount Sharp. This is in detail. Now, it doesn't mean that they actually found a route up through these foothills to the top, but somehow they got around this stuff and got up there. It looks
found a
quite
meteor.
rugged. What's
There's a
that?
meteorite being found. They found a meteorite too, didn't they?
Yeah, that's where we're going.
Oh, that's where we're going. Okay.
Yeah. They found a metallic meteorite.
Whoa. Is that the one you think that created the crater?
No.
No.
Oh, okay.
Now, since I dug these off the web, off the internet, not the James Webb, but I read another article that said that they've discovered several more smaller metallic craters or meteorites just like this around the area, same area as this. So there apparently is a cluster of these types of meteors. So something probably broke up, or they were flying in formation in space or something before they hit.
Well, I tell you, I know an outreach coordinator would love to be there grabbing some of that.
This one would be a little hard to lift.
Yeah,
Would it?
even on Mars.
Yeah.
Okay.
What's Mars gravity is
0.39.
Okay, so 0.4 times.
But now, why isn't there just regular rocks that look like meteorite rock, iron, and where does it come from? It comes from space, and only in space do you get nickel and iron together, never on planet surfaces.
Well,
No, you get them. Go ahead.
go ahead, Jerry.
Oh, you get them in foundries where they're building battleships too.
Yeah, yeah. I mean, they come from a body that's big enough that it had enough internal heat that they melted, and all the heavy stuff ends up in the middle, and then it gets broken up in a collision. So this is like a natural foundry out there.
Right. So that process is called differentiation, and it means the heavy stuff sinks to the bottom, and the light stuff floats to the top, just like you'd expect. And so this was at the center of something, a planet or a planetoid or something that had actually formed, became round and melted and differentiated. And then it hit something else of like size, and all of its constituent parts were scattered all over the place. This shows the meteorite in situ, in its in situ on Mars. You can see these other rocks around that do not look like it. They're not metallic, they're just rocks. And some of these things, this one kind of has a spray pattern around it in the dirt.
That could be wind, you know.
Yeah, that's where I was trying to think of. And those spray patterns seem to exist all over the place here, not around rocks, but they're exposing hard places, or it's just wind moving the dust around or something. But there's nothing else in here that looks like this. So,
But if it got buried, which one would think happens to meteorites or meteors when they become a meteorite, it would be buried. But that light wind of how much, 1% atmosphere that we have is enough to uncover it, you suppose, over the eons?
It's been there for billions of years, probably. It could have been buried deeply in its own crater, and then something else hit and blew that crater to smithereens, and then the wind blew the dust off and stuff. So
but they don't think it's part of the biggie that made the crater. It couldn't be pieces everywhere.
Oh, for
what we're looking at here.
Yeah,
could be, but you can't say. That was a huge object, and other pieces would have tended not to have landed right in the crater. Plus, the crater's not its original depth. This wind has been blowing stuff into it, and water potentially has been carrying stuff into it to where it's not as deep as it was initially now. So it's more likely a newer arrival.
So we now know that there was water there.
Yeah, I think it's highly likely that there was water there.
Well, are we looking at something that has basically the same stuff that's in that 5-pounder that Chuck likes to show everybody?
Yep.
Same stuff, nickel and
Iron and assorted junk, probably in slightly different proportions, but
well,
But it's very similar.
yeah.
forgive me for going off on a tangent, but iron, when a star is making the elements, when it reaches iron, it explodes. And is that when it makes the iron, or does the iron get made later in those lava pits inside the rocks you were talking about?
No, it
Made in stars?
it gets made in the stars, and then it's incorporated into those bodies, so it's already there. And then when they melt, it ends up sinking to the bottom.
Mhm.
But
It's not like it gets made in the asteroid.
But it spells the death of the star when it reaches Fe on the
Yes.
Yeah.
the
There's a lot of natural iron from Mars on this thing too. You see all this reddish dust. That's iron oxide, which
So
is
there's
why Mars
oxygen
is
there.
red. What's that?
There's oxygen in the atmosphere.
Not so much. It's all in this rust.
It's all
You can process the rust and you can get the oxygen out. They landed something with the latest rover that went out and made breathable oxygen out of the CO2 in the atmosphere. That's a different process. But you can also process the rust and get the oxygen out of it.
And the soil had a high iron content, and there was probably water in the past. But once you lose your magnetic field and the solar wind starts dissociating the water and breaking it up into hydrogen and oxygen, the hydrogen is lighter and it can escape, but the oxygen may end up getting bound to the iron, and you get a lot of this rusty dust.
But as thin as that atmosphere on Mars is, it's mostly nitrogen, isn't it?
No, it's mostly carbon dioxide.
Oh, okay. Made from just the iron, the oxidation of the rust, or the iron becoming rust?
No,
Is that
no.
has
No,
nothing
that's
to do with-
different. I mean, there's carbon dioxide that forms, and there's also was water, but the water is easier to dissociate with ultraviolet light. And so that broke apart the hydrogen and oxygen, and that oxygen probably got combined with iron compounds to give you this rusty dust. And it may have been combined with some carbon compounds to give you some CO2, but I don't think that's a big mechanism.
You know what's interesting about this is that I understand Venus is also mostly carbon dioxide, but it's 900 times the pressure and heat.
3,000 times the pressure at the surface. Like,
Okay.
well, it's like being 3,000 feet underwater. I can't
Yeah,
say it 3,000 times, but yeah.
And so we can't see the surface of Venus through its carbon dioxide atmosphere, and yet here's
Except at certain like radar wavelengths.
Oh, yeah, I know that, but they're both with CO2, and yet this is 1% of ours, and the other Venus is 1,000% of ours.
Yeah.
It's amazing. Same stuff.
We did get a look at Venus's surface through the atmosphere with a space probe that flew by, and
Really?
it could see faintly through the clouds in either it was infrared or ultraviolet. I think it was the Parker probe or something that went by on the way to the sun. So
I was thrilled when I saw the video from the Huygens that landed on Titan, Saturn's moon, and because it's a big fuzzball, you can't see anything because of its atmosphere, and yet there was the shadow of the parachute going slowly down over that, that desert of ice, whatever that it crashed on. That was amazing.
That's nitrous oxide that gives Titan its yellowish color.
Oh, it is.
A lot of smog. Apparently, what happens to a planet that doesn't switch to electric vehicles.
Yeah.
And it's bigger than our moon. All right, that's
Now, this is a close-up of these features.
Wow.
And those linear features are pretty interesting. That implies that it really broke up, because it looks like an Earth meteorite called Sikhote-Alin, which has a lot of regmaglyptes that have features like this sort of linear, almost rectangular gouges.
And such meteorites were once the source of Iron Age collection, knives, King Tut had a dagger buried with him made of this somehow.
Yeah.
Inuit natives, Greenland, up in the Arctic.
Yeah, the Inuit, and that's where that big meteorite that's in the American Museum of Natural History in New York came from. Peary or somebody swiped it from the Inuits, and they considered it a holy object. And so now there's kind of an agreement that they've loaned it to the museum to show, but if they want it back, they can call back on it.
Was that right? How in the hell do you suppose they turn these things into knives? Or
Pound them with
spears?
rocks for a long, long time.
Pounding with rocks. Interesting. As fascinating as those planets that are made of diamonds.
Yeah, I'm not so sure that we're going to find a planet made of diamonds. When they claim they find diamonds, it's dust of them. There's not one big gemstone like Uncle Scrooge's money bin.
Yeah.
Starts as black coal and it gets squeezed enough that it becomes transparent somehow.
Yeah, it's just another crystal structure for carbon
Oh,
that
gotcha.
we can completely reproduce now on Earth. I mean, you can make gem quality diamonds artificially that actually perform, they have fewer flaws. And some jewelers apparently can't tell the difference between artificial ones and natural ones.
Oh, yeah, I understand they're selling them, the artificial, they're in
Yeah,
range.
they do. They have to label them as such. But diamonds were never a rare commodity. So
Really?
yeah, they're a controlled market.
Yeah. De
Large
Beers
ones-
kind of holds them and dribbles them out.
I think they contain about 70% of the market in diamonds and Russia the rest. But I know for scientific research, you can get industrial diamonds, inch by inch slabs of gem quality diamond. You have to sign a paper that when your experiment will use up the diamond and it will never appear again on the market or anything.
Use it up?
Yeah. And
How do you use up
we
the-
proposed a lander for one of the Curiosities that had a chemical lab in it, and the bottom was about a 2-inch by 2-inch diamond window, and they were not that difficult to obtain.
Well,
And they
So
use
that's-
sapphire for a lot of the apertures on
Yeah.
aircraft sensors.
but when they find a diamond in the wild, it's a big gnarly ball of something and it somehow becomes flat facets. How in the world do they cut them?
Oh, they carved them into the facets,
With what?
other diamonds.
Other
You-
diamonds.
You give them a sharp tap and they break along the crystal lines. So that's how you get the facets. We got a
Okay.
question from Tim here. Are there still plans to use balloons on moons for data collection like on Titan? And I know that was a big thing they were looking at for Titan, but now I don't hear that much about balloons being used on Titan as I do about drones that are more like propeller driven, like
Yeah.
like the one Ingenuity on Mars.
Yeah.
But I've heard now about plans for balloons maybe on Venus.
Okay,
You want a thick atmosphere. It really makes a balloon efficient.
it does, but the atmosphere on on Venus is very caustic.
A little bit nasty, yeah.
Should let China do
Apparently-
it. They're the ones. They're the ones.
Apparently,
with balloons.
the atmosphere at the top of Venus is about the density on Earth, and it's not acidic. So the idea is you could have permanent blimp-like structures floating in the upper atmosphere of Venus. So
Not that
I
high.
don't know what would happen if you ever sprung a leak.
Yeah. And there are science fiction stories about large whale-like creatures on planets
yeah.
with thick atmospheres that live in the upper layers.
Well, they'd probably send up their F-22s and shoot us down.
Yeah.
Okay. I think
We'll
that
never
uses
see
up our
that.
time.
We'll probably never bring that here, will we?
No, probably not.
How we doing on time? Oh, we're out of time. We got so swept up, gentlemen, the three of us. That was a good meeting.
Yes.
But we did miss our incredible former professor from Westmont College, Mr. Whittemore, who edits and produces our monthly newsletter, and spam collector, who was the man in charge of the local theater organ society. Bruce was not there. I guess you had a grand time Saturday night, and Friday night we'll meet you at Westmont. What time? 7:30?
7, but it looks like it's going to be cloudy with possible rain. So we'll see how that goes. It might get canceled.
And I'm getting the feeling that a lot of things that we get booked into schools, sometimes they get canceled for whatever reason. And if we get rain, good luck.
Yeah.
Can't do much.
We do have 2 schools this week too, but one looks good on Wednesday night and Thursday night looks iffy. We'll see.
Okay, well, in 2 weeks from now, around the 1st of March, we will hit our 2-year mark doing this Monday morning thing. And most of us have been here every time. Thank you, gentlemen. Chuck, Pat, both your Pats, and Jerry. We'll see you next Monday, if not at Westmont's